Hi, everybody. I'm Mark Landry, as Blair said, and we've done a part one of this, which is available on YouTube. So you can watch that to catch up if I talk over some things or you're not familiar with it. So it looks like a handful of you seen that, but many have not. So we will, as this is a brief recap, so the very first thing we'll do is talk about a little bit, so it won't be totally foreign. But this time we're going to go a slightly different direction and talk about some of the use cases that we're seeing. So, and that can help everybody, whether you're new or not, kind of recognize what these are. These document AI use cases. Document AI is not like a major AI use case almost in itself, like tool of the last while is sort of rare, but it's very powerful and it's gaining a lot of traction. It's important with us, and we're seeing a lot of other people invest in this space. And when we talk to clients, I suppose there's a lot of times where people aren't really cognizant they even have a document AI use case, and they might lay around. If you had this tool, could you do something with it? So we're sort of in that stage versus a lot of other machine learning techniques that you can read about all over the place. So it's a little rarer, but very important. And the last part is we're going to spend about half the time on that, probably a hands-on follow-along lab practical examples. So, but still, if you're not familiar with it, don't have access to it, don't intend to follow along, you should still be able to keep up. I'm mostly going to follow our documentation actually, but just expand on some things we didn't talk about last time. And this time we've made the data source available so that you can follow along. And even if not now, this will go on YouTube so you can follow along. Later, you can pause it, you can do some more stuff. We're going to share a small data set. We've also shared a bigger one. So even if you do follow along with that, we're going to build things that run a little quicker for the purpose of this demo. But it's the same idea, and we'll share both sides of that so you can run something bigger and actually try something out. So with that, let's start with the overview. So this is going to be similar to last time, but sometimes good to hear it. It's good for me to change the way I present this all the time. So moving left to right here, document AI is about documents, not surprising, but documents, some people think of that as PDFs, but images are a really common thing to do here too. And so, camera phones, faxes, as you heard Bob Rogers talk about with UCSF earlier, we find all sorts of clients that will have kind of low resolution sort of documents, maybe stored in PDF, maybe stored as an image. The format doesn't matter too much. One exception is that sometimes you'll get a nice and clean document saved digitally from the start, from a web page or something like that, or your ERP system creates something. And there's extra information inside that document. There's a special class of PDF with embedded text, we call it, and we'll talk a little bit about how that makes a difference. So start with those documents and run through a pipeline, which in this case, I'm going to cover a few main phases. You'll see them in there, and then I'll go back and talk about them. But we're going to ingest the documents, generally turn them into images unless it's the embedded text. We need to be able to see them. We're going to run intelligent OCR, so that's optical character recognition. So we're going to recognize the characters from an image. And so one thing you'll see the tool do is paginate some of those PDFs. And then we'll run them through the OCR so that we will use a language model to understand the text. But that we actually use a multimodal model, so different modes of learning. Text is one, the layout is the other. And so we need to see, again, not just what the text is, where it exists on the screen. And when we use these models to do our two main tasks, entity extraction, page extraction, the last bit is how there's a little bit of post-processing sometimes. We'll cover that lightly here. We'll show you what it is, and you can actually use your own demo if you want. And then the last part of this, so that's the main building blocks of getting a document AI pipeline together. And we're going to productionize that with a REST API here as well. So again, ingest documents, run some intelligent OCR to read the characters from them, use the embedded text if we have it, train a model, and use some post-processing. Those are our main phases of what we're doing, and you'll see that our UI is laid out that way. Also with the UI, a big difference between this, there's a lot of unsupervised data in the tabular world, but most of the clients do not have labels for document AI. So a big part of what we do with the product you're about to see is this first one here, the self-service labeling, validation, and refinement. So I know this got great. So I'm going to move that around. Sorry. Okay. So labeling, validation, refinement. So you can get started. So if you load documents, we're going to teach a model how to use them, and it works the standard way with machine learning. We need to teach it with the answers. And so, we're working on some that where we can provide you pre-trained models. And so that's a slight exception here. You can take those in as well. But a lot of people start from nothing. And the strength of our tool is actually coming up with a custom schema that perhaps nobody's ever had, or it's just rare enough that we've not really seen that before. So you can start by annotating the documents on the screen. So we provide an annotation interface that is fully hooked up with all the parts that we need to get a model trained. And so also, once you have a model, you can refine, you can predict against new data, and the predictions themselves can be used as new targets to a model to expand. And it may take an adjustment. If you're getting a model off the ground, it may make some errors. You can correct those errors, add it to the data set, and therefore incrementally increasing your data set as you go forth. And so that's the powerful thing. It's a big part of the tool we've built that processes the workflows, but also allows you to visually see the documents, interact with the documents, both creating labels to start, refining labels as you have a mature pipeline or as you're growing your model and growing that data set to be better and better, the model stronger and stronger. So you're going to see the training user interface. We'll talk about that quite a lot today. And the integrations, we'll touch on that at the very end. So when we get a model we like, a pipeline we like, using the OCR, using all those phases I talked about, we're going to deploy that pipeline, and you'll get something that's a REST API that can score and can scale. And so our pipeline is built for Kubernetes. It's built to scale, built to add more nodes as you see fit with your use case, whatever the volume is, to put it out. So it's just a matter of adding more nodes. And at the end of the human in the loop, I jumped out a little bit, but the review and the correction. So this is sort of the phase of interacting with our tool. We've set it up so that you can interact with those predictions. You can review those, you can correct those, work on a stronger user review interface, business and facing user interface, but you can continue to add to your data set here. So this is about what it looks like. This is what most people want. So I breezed over those terms. So let me go back a little bit. In the middle, entity extraction and page classification. Those are the main two. There's a couple other things you can do with Document AI. Those are the main two things people do. Entity extraction is called a lot of different things. Named entity recognition is a popular one that's usually generic. We're usually going for custom, but the same principle applies in NER. Page classification is just if you look at a single page of that document, whether it's an image or a PDF, what is it? And so people classifying different levels of documents, what processing in different ways, trying to separate things, enabling workflows, and then often your entity extraction runs at the end. All clients we've had so far run an entity extraction task. About half of them also run a page classification task. They still want to separate the pages. They're not sure what's coming in. So you can do those two things in the tool. Here we're looking at an example, sort of a trivial example of what Bob Rogers was talking about with UCSF. They get these medical referrals in. This is actually the example we'll see. We have some trivial examples you can play with, but they're of this type. And so we're going after specific information on this form on the left. And this interface on the right is one that's sort of designed to show you what we're going for and process the full thing. So we walk down the right side. The actual class is the part on the bottom right of each of these. Patient DOB, patient name, referral date, referral reason, refer clinic. There's a few more you'll see in this data set that we have. But things like that are what we're going after for this page. And this is important. This is custom. This is usually up to the user what you have. We even have common supply chain cases. And often, as we've grown that over time, we have a common set of things that you want from a supply chain document. But certain customers want one or two extra things. So the schema is custom for what you need out of it. And it's what you want to do with it at the end of the day. It usually dictates what you want to pull out of this. Some people already have processes set up, and this is the way to replace that. Either way, you want to think about what you're getting off of here and pull those out. So here we see outpatient psychiatric clinic is pulled out. It looks like this is a referred clinic, but we've got different clinics here. We've got the date of referrals pulled out. And this we'll get to again in the demo, but the way that we handle this with Document AI, we're not looking at the surrounding context. Our models are going to see all the data here. So I talked about being a natural language processing model. But the natural language processing model uses all the context of the screen to deliver the specific output you want. Now, in this model, it contains a little bit of that, so it's a little difficult to see sometimes. We have date of birth pulling in, we have name pulling in. And this model is very confident. But generally, clients don't want, and this is actually, I think this is an artifact of the way that the model, we inferred our labels from the start. But usually you can go after directly the data that you want, so that June 24th, 2015 can be parsed into an ISO standard date, sent on its way, and just used as in a database or any other kind of process that you need. So here again, we're taking extracting specific pieces out of this document that you want for your use case. Pretty much as simple as that. We'll talk about some of the use cases, I think, right now. So these are some of the use cases that we have come up against. I think last time I said, you can do about anything with these processes, and you kind of can with documents. So we're just sharing a few of these. Again, because once you think of what it can do, especially as we move down to the bottom of this list, so there's a few different key aspects of how this is laid out. So things that you might not have thought of. So if you're familiar with these, if you've already been working with OCR, you've perhaps wrestled with a spacey model with, again, NER or something like that, you're just trying to get dates out, something like that. If you're familiar with this, or all the way up to what Document AI other solutions are doing, our solution is doing, you can kind of process anything with a document, think of what you need with it, and we're going to show you some of the tools so that you can get there, specific to what you need. Again, just a custom named entity extraction, you can think of it that way. Token classification is what we call that. That's sort of where it is. So the top, this is organized into a key component of the use cases. So a lot of these are validation. It doesn't have to be, but validation is a generic term I'm using here. Is we've got a document, and we're trying to validate that the content from that document matches what we have in an external system, often a database or some registered system coming in, or it could be an extract that something sent, and you're trying to see this. In fact, that's sort of what this cargo airline was. The airway bill design is that you've already digitally got an electronic version of that. But for some reason, there's a piece of paper that accompanies that actual freight, and you want to see that that piece of paper aligns with what your electronic record is. And that's what most of these are. So the bank ID documents is the same sort of thing. This is like a know your customer initiative. You've registered the customer's account, and many governments around the world require that you understand, you ensure that that is your customer. And so the ID documents like a driver license, a passport, or things like that are often required to ensure the identity of that bank account holder. And you can see here we've got 6. In fact, this plus is there's 2 people using these invoices in this way, all in a validation setting, and even partial validation. This is a bit of a mix of whether it's the only source of truth for that document or the validation. And so here, proof of negative test in a bank statement. Some pieces of that information were known, some weren't. And digitization, that's just a different category of this is the only source of truth. And actually physician referral forms that we'll look at today, which are inspired by the real use case, again, Roger's talking about with UCSF. So important use case for us. So these physician referral forms, there isn't anything known about the referral form when it comes in. There's no secondary source. You could argue maybe there's invalidation. Sometimes they'll know the patient, but often they won't. And even if they do, it's not a direct link necessarily. It's just that they have an inventory of potential patients. And the same with this healthcare. Healthcare is the industry, but it's a purchase order for supply chain. Purchase order here. And then judgment's a really interesting one, sitting on its own. Adds a flavor of validation as well, in fact, but it's put in its own category because this is an interesting one to us again, that as we get familiar with this, thinking that it can do named entity extraction, classification, I guess this is a part 2, if you've seen what this can do, and sometimes even I guess I and probably others like almost pigeonhole it in a bucket that it's just doing that sort of thing. Just tell me, just get stuff off of that form that I can sort of see for myself. Humans do these tasks actually very well. So a lot of times we're trying to scale with a system that can replace humans and let them do something a little more fun than alt-tabbing back and forth between a PDF and a system that they're trying to check with all these validation use cases. But we are using a strong natural language processing model at the end of the day, And sometimes it can almost be surprising what that can achieve. And so here you're at more traditional NLP use cases that they can do. So in this use case at the bottom, this judgment, the statement understanding, I'm not going to speak too much about specifically, but we're seeing a large document, 60 to 100 pages on average. And we're looking for specific types of the way that some of the information was recorded on that document. And there was a specific, there was a use case that depended on two different types. The way it was described could be of two different flavors, and people could understand those reasonably well. We annotated those, what they were going after, but it wasn't even still perfect. But I actually suggested at first, maybe we try just extracting the fees and then later using a separate, stronger model to try to divide them into A and B. And the customer went for doing both at one time anyway, and it was very successful. We had, our F1, our recall and precision were both in the 90s. So I guess it didn't blow me away, as almost just show me that these are powerful models and remind me that we don't just have to extract data from there. That's an important part of it. That's where we see most of our use cases. But we are using a very strong model that can achieve more than that. If it sees these documents, if we can frame the problem in the way that we're doing, and we are able to do that for this judgment use case. We'll add more problem types to Document AI as we go forth, but most of the things we're doing, the page classification, the token classification, are what gets the job done, and it was able to for that one. So these use cases, it can be documents. I'll kind of even go a little off this list a little bit to talk about some of the things that we see that once you get the concept of what is possible, certain things just come up that may be a little smaller in scope than you might think. So incumbent processes are very important. In fact, I'm going to move over here just a little bit to get this on the screen. Is one of the questions we ask people when we do go look at a potential use case. Is it new or is it an existing use case? When you have an existing use case, you can really understand where things are at. Usually there's people involved. Usually your goal is to reduce the number of people. So let the tool do all the simple stuff and maybe have the humans waiting for the tricky stuff in there. A lot of these validation use cases, they wouldn't be done if they're sometimes wouldn't validate. There's usually not a reason to, there's usually some discrepancies in there. And so letting the humans focus on those discrepancies, pointing them in the right direction, doing the job for them when it's simple. These are things that are all come into these use cases. And it's an evaluation for every use case. It's your tolerance for all these things, and it's different. There's no way to look at these one way from another. So if I'm backing up to where I was trying to go with this, but we looked at some bank documents, and once someone kind of understood what was going on, they realized there was something kind of simple that they had not seen. It wasn't necessarily a super high value task. It wasn't something that humans had done because the scale of their documents was huge, but they realized it was just the hours of business, and they had it on a lot of templates. And can we use Document AI to find those and show us where they exist, point us to there so we can review the language as we have kind of some of the shock events that we've had over the past couple of years with COVID and supply chain issues and how that affects things. So it's kind of a simple task. And in fact, Document AI does very well in that situation. A lot of times those hours are portrayed very consistently. And so it would not take much training data most likely to get that off the ground, but it just gets your mind going. And so that's essentially where some of these, so I'm going to bounce back and I'll go back to this one just a second. So looking at these lists, we have a variety of industries, we have a variety of documents, validation and other, that's kind of a use case type, but the actual document itself, just be thinking of, it can be anything. It can be digital documents that are just sitting out there, which sometimes are used as source of the truth. It can be surprising sometimes. In fact, with these statement understandings with several of these documents, a digital copy exists somewhere, but yet these documents for some of these customers are used as the source of truth. And that's very interesting. So you might almost, I've had a tendency to do this again, overthink, why is this necessary? They must have a digital copy of this already. And sometimes the answer is no. And so a pile of documents stored up over time as a source of truth, perhaps a database gets migrated or moved around, or ERP systems are combined and things like that. Perhaps it's just easier there, or perhaps you don't have access to it. So the physician referral forms as an incoming document, as we'll talk about, they don't control, it's the variety is high because everything coming into UCSF from all different clinics is often on the template of the referring clinic, the one that comes in. And so they don't get to enforce a uniform standard. So you're not working with a single template, and you've really got to generalize your understanding of what you want from that document. And that's a little bit bouncing back. Here we go. So again, let's take note of one view and a potential use case. Is it new or existing? There's no right or wrong answer to this, but it's usually an important facet of trying to figure out how how we're going to perceive the document AI use case. Having experience just helps in general, because people know the documents, they know where they're from, you can evaluate them, you can see or at least understand a lot about the document quality that's coming in. And most importantly, how is that problem handled? As we're looking at the second bullet point, the use case type, is it validation versus a single source of truth? You saw some other use case types I had broken them into, but these are two really big ones. So the validation use case is definitely interesting, because it bounds the problem a little bit, and people are already doing it. And so you have to think of how can we help, not necessarily how people are already doing this one. Maybe it's a validation you haven't been able to carry out, and now you can. Maybe you can do it at speed that wasn't possible before. So there's different ways. So it can still be new, but the validation use case, you have some different steps you can take when you have a prediction and you can bounce it up against another one. Most importantly, you have a sense of whether it's right that's a little stronger than the model's confidence itself, which we like to calibrate that as much as we can. The stronger the models, these calibrations will be coming out. But no matter what you do, as anyone in machine learning will know, no matter how confident you are, mistakes will happen. The tool's not perfect, just like any machine learning model. Even humans aren't perfect in a lot of these use cases. And so that's really kind of what it gets at. It's hard to almost say this, but what we look at is the tolerance for errors, understanding potential errors there. So with an existing use case, you sort of have a framework set up with that. How is this going to work? How are we going to validate this? How can we be sure that the model is correct? Well, in validation, we can have one extra step there. So that's that really helps these get off the ground sometimes. It helps you focus, especially. So a lot of ways a human will still touch it, will look at it. And what we're looking for here is to speed them up through that process. The return on investment is usually time saved. And so how can we get, if they're spending something like 30 seconds per document, can we get it down to where on a clean document, it's only 2 or 3. And if it's a difficult document, it's maybe that same 30 seconds. And it can be the same even on the harder ones, because we can point them straight to where we were close, if we are in some cases. So if something doesn't validate, especially on something like with some of the audit use cases, the natural documents did not match almost 20% of the time. And we can show exactly where that figure is, rather than going through pages and pages and pages and lining up accounts. The tool's already done that. It's lined up an account, it's found the balance. So whether it's right or the document itself is wrong, either one looks the same to a human if you're validating that and you want to check that. And so the tool, knowing where everything is in the document, can also speed people up. And so with those 60 to 100 page documents in that last use case, there for judgment, that was a big part of the ROI on that one, is that we can sift through that large document, and there's not rhyme or reason to that specific document. Sometimes it is, it's early, or it's in a certain section. Humans can be quick with that. So you do want to take note of that. Don't underestimate human process as well. But in that case, it was much faster because we were able to deliver the ranked predictions of where we see these, and usually the first case is going to point in the right direction. You can see others if they existed, especially if they're not in just one section of the document. So the machine doesn't get tired. It's going to review every single page if you wanted to. We have some people asking if we can only do a couple, but it's going to look at everything and show you if there's some on page 27 and some on page 53. And a lot of times people might stop at 27 and not go all through to 53 because they think they've seen what they want. So all these are kind of reasons where we can succeed, we can speed things up, we can do things that humans don't do either well or they don't do fast. Either one is a good opportunity for a document AI use case. So last bit, last couple, both the same kind of thing, really. Document availability and variety. We're going to play around with a document set that has 5 documents for speed reasons. We got 100, and that we'll send you if you want to play with it later. But document availability, if you don't have access to the documents, it's going to be very tricky to work in that use case unless there's already a model that exists. And so we have some supply chain models to start, because we've seen enough of those use cases There are occasionally some out there. You don't find a high prevalence of like Hugging Face models that you can just use for what we're doing here. But occasionally they do exist, and that's the way Document AI is moving. Is as we see more and more, we'll see more and more pre-trained models. But the majority of our customers, the supply chain use case, the different aspects of where they're at with the supply chain, some of those are, one of those is listed as contracts, very different from invoices or receipt. So even with familiar, documents and processes, document types, we still have slight differences with our customers of what specifically they want to extract or how they get it. Certain models may work or not work for them. So we'll see both sides coming up. We'll get better and better pre-trained models as we go, but people are looking for custom things that sometimes the pre-trained model may start them off in a right area, or there may just not be one. So we did not have access to a pre-trained model for physician referrals. But they had been using a template process from the start. They brought in a lot of data, actually 150,000 so trained pages. I think we even did that later on a second round with more data, but a lot of data to get that going. So your experience may vary. So document availability and variety. So is it just a few? Then that's going to look like a template. It means it's going to train quickly, and we can handle those too. You'll see, as I probably talked about last time, one of our differentiating factors, as I talked about, is this custom menu. I keep talking about the custom schema that people want. So with another really popular avenue with Document AI is working on templates. And so a lot of the vendors out there are just aiming specifically at template. If you bring us the same document every single time and the content changes, maybe occasionally you get a little bit of variety with how that form looks, but it's generally the same template all the time. Your strategies are different. We're using something that goes for the variety that a template method generally cannot handle. So we are backing it. We have some template methods as well, so that we can succeed at an even higher level for some of those, but we still work it through as a custom problem each time. So the document availability, can we get access to those? Can we train those? Can I annotate those? And the variety, just to be understand, in the UCSS referral case, they don't control it, probably likely 1,000 different cases. There's a lot of provider groups around the country. We saw this with the audit use cases with the banks. You get a typical Pareto type principle, not quite 80-20, but something where, but thousands of banks out there, and every single bank statement you would get or audit bank confirmation would look differently. So the last one, available targets. Are there any? Usually there are not. Most of ours there are not. So that's, again, why we'll focus on that with what we've with the tool. But if there are some, if there has been an incumbent template process or something like that, someone's got some business rule process that's been trying to get close and it's been refined by hand over time, you may find yourself that there are targets available. So that's a question. Most of the time for us, they are not. So these are some of the things to think about. You can put other things I haven't covered with this in the chat. We should have a few minutes for chat. Last time we did this on the session 1. It's not quite a YouTube video, but there was a lot of good questions. So I do intend to answer some questions in chat. If I've anything else you want to ask about, would this be a good case for Document AI? Would this be a good case for Document AI? So with H2O Document AI is the tools you'll see here. Document AI is an overall industry, but still new and being defined in different ways, and people have different takes on it. But I think everyone would probably say that this question, isn't it just OCR? It isn't. So if I process, let me get one on the screen actually before I show this. I'm going to back up a little bit. Okay, so if we have this referral form over here, isn't it just OCR? If it just OCR, would be taking all the tokens. First of all, we're reading things left to right in an order that's not straightforward. We're going to say fax completed form 2, data referral June 24th, and then we're going to get to where the fax completed form went, outpatient psychiatric clinic. If it's just OCR, especially the standard OCR that doesn't even use the pixels, just I OCR it, I copy paste, I put it somewhere, I work with this as text. It can be done, but you need something to go through that. So what people I think really mean is, isn't it just OCR and business rules? That's probably, you have to at least add something there, because it's not just OCR, or you couldn't figure out anything about this document really. You just have the text. So at its literal, is it just OCR? You just have the text. You pile on that where we mostly see people trying, especially those that have tried and failed. Well, I tried some business rules, it seemed easy. I tried, again, like I said, like named entity recognition, like a spacey model to find the date. But there's multiple dates on this form. I've got November 11, 1977 here, the date of birth. I've got June 24, 2015, the date of referral. There's probably other dates on here. We commonly will get multiple named entities the way we typically think of them from traditional NLP models. If we're just classifying things as a type, a person, pronouns, things like that, places, phone numbers, you can usually find this out from existing models that have been there for a long time. Dates especially, it's a pretty easy one to go after. It's not as easy as you think when you write that code sometimes, to be really precise about it. But that doesn't tell us which date is which. And so you can try business rules that go hunting around left to right, looking at things, but there's certain things that a lot of times the form, especially when you look at things from the header in the form, like an invoice number, something like that, doesn't even have any context sometimes. It's just a number sitting out there in the open. And we all sort of understand when we work with these documents, oh, that's the invoice number. Okay, it's fine. That's the ID number for the document. Or here, this is the clinic who's sending the referral, because that's who filled it out. So these sorts of things, this is where the model comes in. It's trying to separate these with many candidate things in here. If you try to write these business rules, they're very difficult. If you try to write models that are not custom for this task, you can usually get to a certain threshold. And sometimes maybe that threshold is good enough to get started. But the models here really are what are allowed to surpass that. And I say that, and in the first talk, I talked about the first part of this make session, talked about that a little bit. We used the wrong model for a while. We were new to this space when it was brought to us a few years back. We've got experience with this, and we tried that way, not necessarily just OCR. We knew there was some modeling behind it, but we put models that weren't custom to this task in. So that brought our ceiling higher than, is it just OCR and business rules? But to use the right models was necessary for us, for our use case. And so it's not a guarantee it is, but we have the models that can do a better job. And so that's where we're putting those differences in place. All right, with that, let's flip over to the demo. Here we go. Okay, let me get to one more slide, sir. Skip the slide setting this up. So for those following along, or who will follow along later, which I would gather is most people, but here's what we got. So for a login, if those are following along, would be ready with this. So the free trial, you can go here for a free trial of all the H2O products. Pretty simple form. That's how you can get access to our demo cloud. And so you can try this for yourself. So that can be accessed through this link right here. So Document AI, cloud.h2o.ai. If you get regular cloud, you're familiar with that. If you're familiar with driverless AI, this is a bit different. So that link right there will get you straight to Document AI. So we're being cautious of how we push that out there as we gain more and more. It's still an evolving product. Again, I probably talked about that last time. So the product is new to us. This user interface we're going to walk through really started taking shape just the spring of this year. We've been having the library behind it for a year before that, and arguably doing these use cases for another 2 years before that. So that's sort of the chronology here. So we're still iterating on front end, and actually we'll have one of the next releases, we'll have a different look and feel to it. It's a similar idea overall, but clean some of the things up in there. The documentation is really key. So I'm going to follow along with that. I'm not going to go back and forth between it, but it walks you through the same thing I'm walking through here, and it has, and that's the way to get started. So, but I'll add some color to it. You can watch it in action. You can try it yourself, of course. But if you get lost and I'm not covering something, our documentation will cover that as well. And so there you have the link straight to that. I'm sure there's other ways to find that, of course. The data, that's a very big part here too. So document sanitation is available. So there's a Google Drive link there. This should be publicly available. I haven't battle tested that, but it should make accessible 2 key documents we're going to use for this. So the document set and the annotation set. We'll get into all that. But you've got 2 key files that drive this. After this, I'm going to also put a bigger data set that you can also use, which is just the same thing, just more of them. And then the key pieces I talked about of what we're going to go through in here, we're going to load those documents. So you're going to see what you can do from there. The OCR branches off from those documents. We'll see that in action. Work with the annotations. This, as I said last time, is one of the key parts of working with documents as data. And so then we're going to also train a model. That's kind of obvious. It'll be it won't be the greatest model you can ever do. In fact, it's not very good. But you'll see it will start to learn on just I'm giving you 5 documents. And so we did that for people to try to keep up, for me to even do it at times. So I want to make sure I get on with it, or even I won't finish the 5. But so deploy a pipeline here. So that's why we're going to give you 100 documents as well, so you can actually train a model that that you can see really showing up about as good as what you saw on the earlier screens there. Deploying a pipeline is a really important part of this. And so the REST API, this is the way they're consumed. We spend most of our time, I suppose as a data scientist, you might think it's these 3 steps here, over and over and over, add documents, grow the model, add annotations, keep making it stronger and stronger and stronger until it's sufficient as you like it, or sufficient to deploy, and continue to grow that over your use case. But at the end of the day, you want to expose that generally through this REST API pipeline. So without further ado, let me get into that. Okay, so here is Document AI. I'm using a cloud internal. I've got several different clouds. We have several here at H2O. Sorry, this is the one we were advocating for, but I'm going to use this one for now. So you log in. It's going to take you to a screen quite like this, except for you won't have any projects. So your space is your own. And so the first thing to do is going to be create a new project. So this is the screen that you'll have on yours. So creating a project, really just a container. You can judge that how you want. We usually stick use cases in the same thing, but you can change these, you can rename them, you can use them later. You can delete them, move them. You can train more than one model in them, so it doesn't have to be a single model either. So it's really just usually a collection of documents that are usually kind of similar. So we sort of organize these by document type. So let's call this. Keyboard's a little loud. You can, I usually don't, as I said last time, drop files in here. I usually go one more step, but almost everybody wants to. So let's go ahead and do that. So I've got these medical referrals. So I'm uploading my documents that I just want to get started. A lot of people have one document ready, or just something ready to start. That's a key point here. I'm going to click this and I'm going to talk to you about what I'm about to say. So here's a large example ready to go for you. But here's example referrals, 6.5 megs. We've got just 5 things in here. It's small. This is important though. So file supported PDF, images, zip. What we do need here, we have a new way, we have one that won't have the same limitations, but right now we need a single file. And so it doesn't have to be a single PDF or image, it's a zip file, and traditionally it is. So you can get multiple documents in one shot. However, also that zip file needs to be a clean zip of just the documents. We have a new version that's releasing that constraint from us, but right now you need to load, and the one you've got already prepared for you does this. So effectively Control A your documents and zip them up, do them command line, something like that. What I mean to say here is right now, don't zip a folder. That's a natural thing to do. We're working around this, but we need to see a zip file of just the documents. So I'm going to create my project. So here, this will be empty for you. I've got a few others, so I can show you some things too. Maybe not have time for, see the comes to time. So you have a couple test ones here. So I think make training is the one I just used. So here we see these same kind of principles that I've been talking about. So I don't want to belabor this too much, but we've got document sets. This one's processing. You'll know it's processing for a few reasons. So status, it's got a timer. This will move to a check when it's done, or an exclamation mark if it hasn't gone well, but this one should be fine. Number of documents at 0 and pages. That's not true, but that's our way. We just get to learn when you see 0 and 0 there, or blank, that means it's still processing as well. So several clues that it's still going. This is accurate. It just switched, and actually everything switched. So my last modified date switched, and I've got a check mark now. I can, in all of the user interfaces here, now you can click on this and you'll get the same modal screen here. Mainly just take you to your logs. I didn't even bother typing the description in. You can change the name of some things here, delete. You can do most actions from that page. I myself generally click on these and click the buttons at the top. There's not much you can do with the document sets, but let me show you with the annotation sets. You'll see a few more actions on the top. Again, these same buttons are going to be accessible through here. So whichever one you prefer. I think most of our internal people prefer it the way by clicking on these one by one. So let's do that. From the document sets, there's really only one thing to do. You'll move into most of the time spent with annotation sets. So let's get on with this so I can make sure I don't get myself too late in time. So here's the OCR methods we have available. So I'm going to take those documents, execute the OCR. I'm not even looking at the documents. We're going to back up and show that, but let me kick this job off a little bit. So with the result name, so example tokens, and I'm going to run Tesseract here. You can run anything. You can do that. It's a little faster, but we have .tr. I'll talk about those in a sec as well. So example tokens Tesseract. I've chosen my OCR method. I'm going to click the OCR. I can type descriptions, click the OCR button. That is going to launch a job. So this is a little back and forth so we can get everything in a row, so we can kick these off and get going. So on the jobs right now, you've got two. The first thing I did was upload it. I could have checked the jobs while it was processing. Now I'm doing exactly that. So you see a job type OCR. Most of these will be transparent. Sometimes they won't. This post-process document set does a few things. So you can, based on your naming, you'll see all the clues that you need here. But right now we are OCRing. This job is live, so you can actually see it's actually completed. So it's probably about done. Every now and there's a little bit of wrap up on the Kubernetes job. Fortunately, I'm moving this forward, so I'm not talking about that too much. If I click on it again, it's still pending, waiting to finish up. So what I did when I opened that, actually, let me get one more thing. I know I need to get ready so I don't lose time here. So I've given two things. I've loaded the documents. The other portion is an annotation set. So this is where we have answers. So we're providing one for you. Sorry, it's the original. Let's see. There we go. And import it. This won't take long, but at least gets it going. So we've provided some targets, so we don't have to click there on the screen and label even 5 documents with just a handful of classes. Doesn't take long, but takes long enough. So we've loaded those targets. Now let's check the jobs. Now we've got 3. So, and this is important. So this is running now. It won't take very long. The OCR job didn't take very long, took 52 seconds. You can see that there's a couple things to note in here if you're really paying attention. So you'll see that the workload started, and at the end, we're going to have workloads finished somewhere in here. Yeah, this is some of the Kubernetes finishing up. So there's I'm not pulling it out right here. So we have some timings in here. And then you also have the created date and started date. In the event that you have GPUs in your cluster, and sometimes we're careful with those. And so if it's been a while since you've used the GPU, these are Kubernetes. This is designed to work in Kubernetes. So we may queue up a new worker that we let pause. So it can be a minute or 2 or 3 even sometimes to go turn on a new worker to get that going. So we're going to try and keep the cloud bill down that way. So if it stayed hot, so if we run it again 20 minutes later, it's going to be ready to go. I just say that because you may see a difference in the created date, started dates here, and the log timings. They all match right here because this one's ready to go. So just a slight note, but you can see that there's a couple components of getting this run. So the good thing is we can run multiple jobs. Everything, again, is designed for Kubernetes. It's designed to work on GPU. I ran a CPU model, the Tesseract, but .tr and the OCR sets. Again, in case I get squeezed for time, there's a better explanation of what those OCR methods are in the original video, but let me show you in the part 1 of this, sorry. And I think we've got time notations called out in there too, so you can skip to it. But really quickly, this blue also describes what's going on here. And we're going to add to these. So we're bubbling up the engineering behind this. So we're going to add paddle OCR, paddle, really strong library out of Baidu, gets us, it has some really strong pre-trained models. So we are making changes to these OCR methods. We've refined the .tr model since August, I think, since we did this last. Best works the same way. So let me just describe that. For practical purposes, it's really, you have 3 different single choices here. 2 are OCR, PDF text extraction is just getting them out of the PDF. Best is a way that dynamically tries the PDF to see if it's embedded text. A lot of times when people get embedded text, they're not sure if it's embedded. Any given file, particularly in production, could be embedded, have embedded text in there. So we want to go the fastest way possible, error-free way of using the embedded text, and only use OCR if we need to. OCR is computer vision models. So optical character recognition, the optical, we're using computer vision models to do this. Tesseract is slightly different of the way it processes, really good off-the-shelf library. We don't have time to talk about, but .tr is more standard computer vision for those of you that are familiar with convolutional neural nets. And it's not just a simple classification. For the OCR process, we do a 2-phase, really 3. Check for rotation. The main process then starts. with finding all the tokens on the page. Tokens are space delimited. You can think of it as a word, but it could be ID numbers and things like that are not really words. So it's space delimited set of text, whether it's one character or multiple characters. We're not going to use every single character for themselves. It may differ from how you're familiar with OCR. So when we find all those boxes on the screen, then we send that to what people think of as OCR, which is recognizing what is that token there. So let's put some on the screen. So you have those choices. You can play around with those. You can try some. I actually have fun with that sometimes, trying the different engines and seeing what happens, seeing the differences here and there. What it will look like is this. So we have lots of boxes. We're trying to read everything on the screen, and we see what the value is. So that first pass algorithm had found all of these boxes. And even though this looks really clean, it's probably started from a PDF, I actually sent it an image. So I've supplied all you with images. And so we do have to use optical character recognition here. Even though it's very clean, it looks really, most of this is going to be fairly perfect. It's a pretty clean document. But we have actually had to invoke the OCR to run this. Plus the fact that I actually called on Tesseract anyway. But if we hadn't, it would have done that. So this is what we get from the OCR. For practical purposes, there isn't much to do here. Maybe observe how well the OCR works. And this can be part of checking out a new use case. It's something I do a lot. Fire some documents in, judge the OCR quality here. You can get very specific. If you press the space bar, you can actually see all the text all in one. So it's a little cluttered on the screen. You can just kind of glance through here and see, is it getting things mostly right? Do these seem pretty sane? They look very good from here. You can hunt and see what it is. And that's, again, your mileage may vary on your use case. Do you need the OCR to be really close to perfect? If so, be evaluating that. Be really careful in looking at this. If you do not, if you can handle a few errors here and there, or perhaps even a lot, and it's surprising sometimes, if we have handwriting and a blurry document, we do a good job, but nobody's perfect on that. You can benchmark a state of the art on these. You just have to go in understanding it's not going to be perfect coming out. So that's the main thing to do as an action, as trying to evaluate a use case, whether you're a data scientist or not. Just looking through here and understanding, does this look pretty good? Because I can update something. I don't really have anything to update, but if I thought anything was wrong, I can go in and change it, and I can save that if I want to. This isn't a live annotator. I can do whatever I want. If I thought this box didn't need to exist, I can delete it. I can do all sorts of things with this. And sometimes that's practical to try and help the model a little bit more if there's maybe a high mistake rate. But you have to be thinking that when you deploy that pipeline, these are going to be the indicative errors that you see. And so you kind of have to deal with those and see all one bundle, what comes out at the end, how accurate is that? Is that accurate for my use case? Are we saving time? That's generally what you're thinking. So really quickly, I've given you these annotations. You'll have them yourself. And I didn't even talk about this much. So again, there's two ways to do everything. So with the annotations, now I'm going to click on it, edit and page view. That takes you to the interface that I showed here. This is our annotation. It's also just a way to display things. So like I said, looking through everything. So it's live, everything's moving around, but that's fine too. So I can click on this box, I can extend it, I can do all the things you might think of with a live annotation engine. This is a good one where our active team played around with several. And this is a really good one for documents because we find little characteristics matter. As H2O, we're looking at the annotation side of general tools, Label Genie, some of you may have heard of. But for this one, this is customized for Document AI, the task we're always doing. We're zooming into documents a lot, really fine detail, small boxes. We're carrying multiple pieces of information a lot of times, not in this one. So I've got my label here, but a lot of times we'll pick up multiple things that we're talking about with a document at the same time. So eventually we'll get the text and the label. So here I've switched. Last time when I clicked on something, you'd see what the OCR text was. With these annotations, I've skipped that. I'm not trying to label every single box. I'm trying to label just what I want. And I'm going to pick a label here. So this has been set up for time. I'm going to have to go a little quickly on this one. I apologize. So again, our documentation will take you through this. Glance at it real quick. I've got it up. So you can follow along with, I find that the beginner tutorial is the best place. That's sort of aimed at that. These are going to be the same documents we've been looking at. So let me flip back here. So we've got the annotations. the one thing, it was easy because I've given to you, you don't have to create a project from scratch. I'm going to show you how that would be done really fast by going back to where we started. When I imported the documents at first, we pre-set up sort of a dummy you can think of. It's all the documents. That's useful for just looking at the documents. Sometimes that's interesting. What was even in that zip file, looking through them, understanding them, thinking about how you wanted to strategize the use case. But we've created this one and it's empty, and I'm not going to use it because I've already imported some. But if you didn't, you start with something that's empty. I know that from the attributes. Text is the result of the OCR. Label and class are two different. Class supports page classification. You'll have one label per page. Label is what we've been looking at almost all the time. That's token classification. And so multiple boxes on the screen. You can have just one if you want, but it's structurally a little different. So if I were to start from scratch, what would I do? I go to edit in page view. I'd see these same documents, and I would start down here in the attributes section. So file attributes could be used for class. I typed it in. I can type anything I want, but we're working on making sure we mistake proof here. Class, all lowercase, label, all lowercase, are the right things to drive the model. The models are expecting class for page classification. I can add it here. I can change what I want. I usually use drop down. A lot of people like radio. So doc type 1, I can put a description. Doc type 2 is here. So I've been using the one where we would just label boxes. That's a region attribute where we click on boxes all over the screen. The reason I purposely used this here to show how quick that was to set up, this is already ready to go. The way we'll access this entire page with a single shot is to hit the space bar and go to the file annotations, and you'll see it's these two things I just typed in. As you change this list, they will become available immediately. So you can just change these and move through document after document. This is one, you can swoops. This is one, I click off, I'm pressing the right button here, document 2, and so forth. You can quickly annotate a lot of documents this way if you're just trying to say, what am I? Almost a classification in normal image models. So we've set this up, we've given you these labels. And to train a model, that's usually where we want to see things. So we would do one task first. We would apply the labels. This is something where we've been working separate, if you will, and it is faster usually to do that is to start. Let me get this going first. Go real fast. Apply labels. Shouldn't take too long. So we've got the OCR here sitting in this annotation set, and a different annotation set stores our labels. What we're going to do is essentially merge them together. We're going to run a union of where all those boxes were on the screen here with all the tokens that are underneath it. You don't have to work that way. You could label straight from the OCR results, but by doing it this way, it's usually faster. It's usually because we only need a little bit of the screen. So there's several different ways to do this, but that's the way I prefer, and most labelers prefer to do that. What it means is you're sort of trusting that the OCR will be underneath it and we'll overlap those then. So it's another thing you can look out for when you see the OCR result. But here is the fusion of both of those. So here's the other way that you can go into page view. So now what I'm doing is I'm carrying all the elements. I've got the label, I've got text, and some of this internal stuff that we have. And that was, if I hit the up button, I can see here's my classes. If I hit down, it changes color. And so that it was already on the one that makes the most sense. Both of those are good clues to what you're doing. B takes the boxes off, L takes the labels off. And you kind of need to do all those at certain points. So it's nice to be flexible and change things dynamically with that and quickly. So we can see we've got these views that this is the outpatient. This is the outpatient clinic, referred clinic. Oh, sorry, it says referred clinic, I can't read. So the outpatient psychiatric clinic, 3 different tokens, all classified with the same thing. I imagine if I went back and looked, it would sort of all contain the same box to start with, but now we've merged it with the individual tokens because that's what the model expects. The model wants to see all these tokens individual. You can think of it as almost a row per token. That's how the model sees it. And what it has in there is this label and also the coordinates in the box. So we're not showing the coordinates, but essentially you can implicitly see that what the coordinates of these boxes are. That's what the model we use, this layout model, layout language model I've talked about again, that's more in the part 1. this model is working from all those context clues. So it has been pre-trained on 11 million documents. It understands the structure of documents. It's a natural language model. It's been pre-trained with a BERT style, for those of you familiar with that. It's a replicated BERT algorithm set to documents. So it's gonna arbitrarily roll that, hide tokens and start to learn the structure based on what's the next token. That's the way this has been pre-trained, and we fine-tune that to do the task we want, which is to learn that these 3 words are referred clinic. Or if we do the page classification, look at all the tokens, classify what is this page. This is an actual referral versus a cover page, clinical notes, all sorts of things can be bundled in with common PDFs that are different types. And so some people want to divide those out as well. You don't have to for the job to, if this model can be trained to see other types of data and avoid those also. That's a question we often get. You can do either one. It may be more efficient sometimes to route those models so you don't have to wire them all up. If you get multiple models inside one document, you can route them. But actually a single model will know to avoid the cover page and to avoid the lab notes if it's got enough data. So here again, we're going to try to train this here. I'm going to kick this off, and then I know I have to queue for time. So with the trained model, we've got a token labeling model type. This auto would filter. I haven't to what we have available. So my ABC is the only one that's capable. So it looks through these 4 data sets. I clicked on it, but even if I hadn't, it would know that this is the only thing available. So keep this off. Prediction annotation set. This is, so I'm going to queue a model. Do we want to validate it on data? I can split this. There's only 5 documents here. You can split ahead of time. We're working on trying to fuse these together, make it a little easier to work on. But right now, if I wanted to put an 80-20 validation split, I can do so by going through this split. And so split here, I would have 2 splits, percentage. I'm not going to split it evenly. We're going to go 80-20 and quick. I've done all this in the demo template, so these will all definitely work. So I'm going to have 4 documents and 1 that will go through here. This will take quickly. And then I could train on 1 and validate on the other, the typical way those run machine learning models typically want to do. Check that it works on data that the model has not seen. So you have training on 4, validating on 1. It's not going to work terribly well, but you'll get a model. We can see, in fact, let me skip straight to it. I'm going to show you what we got here. We're going to view the model through the results. So here's OCR and split 2. There's an accuracy tab. I'm going quickly through this. You can pause the video, see the way we have this in the documentation. Here's sort of the end. I'm going to move this to top 2 so we see some of these. So on 4 documents, even though this has been pre-trained, one of the other examples we have that just some of the data in there is I didn't want to share for this one. The typical only use is some internal data on that. So here's something we can share. We filled out that out ourselves on forms that are online. And as 4, we've typically worked with 11 as a common use case, 20, 50. The more data you have, the better the model will work, but the more uniform your data, the quicker it will work, and the more maybe it follows typical patterns that a BERT model may have. So sometimes we do have to hit the hundreds before we can get accuracy that's fit for a use case. If it's really high accuracy, this is a more of how do you value the use case? What is the tolerance for errors? How good do I need this model before I can deploy it? Or even iteratively get something out there, test it, see if it's faster, a shadow environment or something. Maybe it's a little lower than you have to, but the final grade, we've had one that needed to be 95%, and it took us a long time to go after that one. Collecting data, retraining it. The model was not what kept it from being a long time. It was us struggling, trying all the methods and eventually getting it there. But in that use case, we had about 1,400 documents for UCSS referrals. They had about 150,000. So there's no right number for these. Just what we found that the more you have, the better off you are, but the more uniform they are. You can almost think of it as a human, how easy it is if you were to train somebody, how easy it is to do this task. If it's all pretty uniform, it's dates, they're always in the same place. Roughly speaking, in a document, you have 1 page versus lots of pages, lots of nothing to see here, can make it a little slower for it to learn what nothing compared to what you really want out of it. Here we can see this model, even looking at the top 2s, learn much. It's starting to learn the referral reason and the referral clinic. So here we just see our accuracy. We've got 2 different ways of looking at the metrics. So we're looking at classification tasks. So we're looking at F1 score, which is a harmonic mean between the precision and the recall. Support is important. That's the number of tokens. And so it obviously correlated with as much data as you put in there, and how many targets it was supposed to find, but also how many targets, how many tokens are in that target. A date can be 3, December 15th, 2021 will be 3 tokens. So this is a number of tokens, as they are down here as well. So we're validating on one document. So there's 3 in the date of birth, just like I said, only 1 for the patient's gender. So we see F1 scores and in the confusion matrix too. So if I wanted to see where things are learning. So it's got the referral date and the referral reason right when I switch it to top 2. But it's still missing over here. The O is what we're mainly looking for. So this is the column. It didn't predict anything. So it's not sure what it is, because in most of these models, we're not labeling everything. We're only labeling things we want. Most tokens don't get labeled. And so that's a pretty important factor of what the model's learning from. So the more data, you'll get it off of that I'm not sure about anything sort of line, and start to learn things. And you can track that with some of the metrics that we have in here. As if it's really early, like 4, generally we would say you probably want to put about an hour or 2 before trying one of the models of annotating. So, it's a funny unit of measure, but it's not a certain number of documents. So it's just get the hang of it, because a lot of times in the annotation, you may change the way you want to look for or how you label it. But that's usually a good starting spot. Use the annotation set and then try a model and just see. And sometimes if this was done, the 5 labels we've given you here would take almost no time at all once you get the hang of using a labeler at all. So getting them up to 20, 25, 50 it would not be hard for this use case with the number of targets we have. So that would be what we suggest, but the model will keep learning. Well, the use case, that validation, say the judgment use case I talked about, the very first model, we had to look at it just that way. They had about 50, maybe 100 documents in. It was at 0 to start. It was a very difficult problem to get started, but they put more documents in. We could see it learning when we looked at the top 2, just like I did on screen. Had faith to put more documents in, and it hit the 90s, as I already said. So precision and recall, both in the 90 range. One was mid-90s, one was about 90. And for them, that was really strong. That really helped the UI. Their ROI is about 4 times faster than the incumbent process they had of humans doing it, going through that use case. But a lot of them will move off earlier. So imagine I'll use the thing we've just started for this make session to create data sets. So you'll see this Google Drive here has these 2 documents, but public data sets. We'll start to use that and get some more of that so that you can learn faster. We'll get the 100 in and the annotations for there so you can see models. That go stronger than that. So I have gone after my time budget quite a bit. I'm going to start sharing, take a look at the chat. So if you're able to hang on, I'll stay on for a little longer. We do have a little buffer on this meeting. So if you want to leave something in the Q&A, feel free to do that. Thank you all for hanging along. So that's a good question already in chat. So do all the documents have the same format, medical referral form? Very good question. Let me share that to show you. No, they don't. That was kind of an important one. I didn't talk myself out of showing those a little enough. Let me share screen. Sorry about that. Okay, here we go. Okay, so if we go back to our annotation sets here, I'll just show you the training ones real quick. That'll be fast enough to show, do they have the same format? They do not. So here, let me get these guys. So here's a form, here's a form, so they have 2 of the same form. And you'll see with 100 that it's clusters of those, just because that's what we got and filled out. But the real use case, they're all over the place. So there's 3 different forms just in this little training set. The validation one, I'm pretty sure, is a different one, and that's important to know. Oh, cross looks pretty similar. Oh, that's because I went to the same thing. Sorry about that. Here we go, this one. So you do have different ones, and that's a great question. So if they were the same, it's going to fit that document pretty well. And so you just have to be thinking, like every machine learning problem, I want to see that my test set or validation set, ideally both, is going to be indicative when I'm judging the accuracy of this model for my use case. If I deploy it and I've given it 500 of these medical center of Aurora ones, and 500 of maybe that Blue Cross ones, if I'm going to get one of those 2, then I'm in good shape. If I'm not, if I don't know where that next one's going to come from, I better be pretty careful, and I should really throw as much variety in there as possible. That's really important. And it's often, for some of our use cases, we've seen this with, say, bank statements. It was really easy for us to gather the first 10 in mass. You know, we got the big 4 banks, and a few of them have different formats. And so we had 1,000 of them almost immediately because, you know, of some of those. And especially if people have been working template style, that's where you're going to get your labels. If they started with templates and they just got tired of maintaining them, that's really the UCSF story. They had been maintaining them for 2 years, got up to maybe 100 or so templates. They still recognize that didn't cover 40% of their data. And the trouble with the templates is it had no clue about that other 40%. So what we're training here is a model that generalizes, even if it's never seen that document. As we grow this model, it will understand the clues about how the referral date appears. It's going to be different for each of these. Go back into the classes so we can see a little faster. So here we have the referral date. Oops. Over here, the referral date, the one we gave you is messed up. So date of birth, the referral date's not even on this one. And that's okay too. So I haven't really focused. There's a lot of little intricacies we still haven't gotten to in here. Very commonly, I think with the UCSF one, they're going after over 100 things. But on a given document, they usually only have 30 or 40. They've just set it up for the different ways and shapes and forms that different providers send them. So it's okay to not have those. It's actually pretty common to not have those on every page or even every document. It doesn't contain a certain piece of information. So yeah, that's a key aspect of these. You can use templates, and Document AI will learn those quickly. We've had a use case like that where OCR was really the challenge there. So we put our OCR in, which we innovated to get. That's how we got .tr. The format at the end of the day was the same every single time. So some of those airway bills, it's a common template. Every different carrier does them slightly different, but it's a similar form. So the OCR was a piece that unlocked that. It was a very difficult task to do in that one. So it can be, but really where we're situated, especially H2O Document AI has been built to handle where you have high variety, you don't see the same documents, you might not even know the format you're going to get in when this thing is in production. So the key you just want to think about with that is just that while you're creating these validation splits, that you do so that you have the kind of redundancy you expect to get. If you do expect to get the same two, have the same two in there. Have them been in proportion to what you see probably, so that when you evaluate the accuracy, it's about what you expect in the wild. So sometimes even if you do have in the referrals, they are going to see the same vendors over and over again. They're going to have those 100 templates got them the common 60%. So you wouldn't want to go completely with vendors that you've never seen in the training set before, because you'll be underdoing what the model can really perform. So you just want to understand, as with every machine learning problem, try to get an indicative validation set and test it. So good question. One of the bit I didn't show is the publishing a pipeline. This is in the first video as well. And now you can actually test the pipeline. When you have a pipeline up and running, you can drop a file in here and even see. So that would be almost your test set a little bit. We got to be doing this so much, we didn't want to use it through curl requests and other REST API kind of ways of interacting them. So we got that into the tool. So we'll strengthen this too, so people can see the end of the line predictions. With a pipeline here, I've wired up my OCR, my document ingestion, my OCR method, or your embedded text if you use the dynamic, the model that I've trained, and then post-processing, which here we're going with a pretty vanilla post-processor. Again, that's in the previous demo. So when you publish that, you can use some of the things we have. We're also making that easier to use. We use the same two almost every time, actually. It's just common things you have to do. So post-processing, not too difficult usually. When it gets customer specific, the REST API can usually be worked with. It's a familiar JSON to work with. So we have some customers that use some of our post-processing inside the pipeline, and then they also have post-processing that happens after it to kind of do some certain formats and things like that they carry out for their own use case. So a mix of both is pretty common. So you can test here, you'll get JSON back on the screen so that you can kind of see how this is working on new documents. Outside of here, you don't need to do that. The annotation sets will also do that. I've got my predictions. So here was actually what we split out. Taking quite a while on this, sorry. But these are predictions that we have, and it's all text, and you can see. So that was why I had to get it off the 0 line. If we got to 100, we would see them. I'll show you what predictions will look like. My new predictions, here we go. They'll look the same as everything else. They'll just be, there we go. So this is what an actual model predicted that had trained on only 11 documents, 20 pages, has trained on different data set that I used a little more last time. So here we've got a table going on as well. So we've got a lot of different, the labels here. So I'm hitting the up key, by the way. So up takes you from all the things that you can see here. We're having label text and just this ID number. So we've got the text, we got the ID number, we got the label. So you can rotate through those. My coloring's already situated to be what those are. I've got all the yellows for the O's. It looks like it's pre-chosen blue for the common thing that we see here. Got zoom controls and things like that. There's a button over here. So play with it, get a free trial, try it out. Let us know if some things I still haven't covered with the 2 sessions. Go through it, go through the documentation, but ask us questions if there's nuances that I haven't covered here.